one, torque on current loop on a magnetic field. Torque on a current loop in magnetic field. Now, if you check here, you're supposed to find a torque. This is a big derivation. So in this case, if you can see this diagram, in this diagram, see that in this diagram, you will see that there is BC this side, AB this side, CD this side. BC is separated by distance A, CD is separated by distance B, and it is connected to a copper wire with brushes to a battery. Okay, when this battery is on, there will be a rotation. There will be a rotation, that means there will be a torque. We are supposed to find the value of torque. We are supposed to find the value of torque. Okay, so for BC and AD, if you check about BC and AD, so what will happen? For BC and AD. For BC and AD, what you are supposed to find? First of all, you are supposed to find the value of force. What is force? Yes, force will be I into A cross B. So this will be equal to what? When you remove cross sign, you will get IAB sine theta. For BC, if you will check, BC current and A will be in same direction. Same direction means sine 90, sine theta will be what? Sine 0, and sine 0 value is what? Sine 0 value is 0. Okay, now if you will check for AB and AC, sorry, when you will check AB and BC, so what you will get? You will get the value of force as I into B cross B. So this will be equal to I BB sine theta. If you will check here, this B and the current is perpendicular to each other. That means sine theta will be sine 90, and this will be what? This will be IBB. Okay. And then what you are supposed to find? You are supposed to find the torque. What is torque? Torque is force into perpendicular distance. Perpendicular distance, right? Now, what is perpendicular distance? Just understand. See, first it was here. After some time, our loop got shifted here. Gets shifted here. I'll make it down. Okay. So first it was here. After some time, it moved somewhere here. Angle between them was angle, yes, angle 90 minus theta. Here force was acting, here force was acting, and which force will be acting? That acting force will be IBB. Which force was acting? IBB. Okay, this is what this entire is A. This will be A by 2. This will be A by 2. Okay, now what about perpendicular distance? See, this is the perpendicular distance. From here till here, it is perpendicular distance. How you can find perpendicular distance? You can take cos theta. Cos theta means cos 90 minus theta. Cos theta is adjacent upon hypotenuse. What is adjacent? The part which you want to find, x upon hypotenuse. What is hypotenuse? A by 2. That means that x will be equal to, what is cos 90 minus theta? Yes, sine theta. So that x will be equal to A by 2 sine theta. So this will be equal to, this will be equal to, this will be equal to this will be equal to force into a by 2 into sine theta. So your F will be equal to what? It will be equal to F a by 2 into sine theta. And see, in this case, there will be two perpendiculars from here till here. Here also the same factor will be there. So I will just multiply it by 2. So this 2 and 2 will get cancelled, and we know the value of force. What is the value of force? IBB A into sine theta. IBB into A into sine theta. Acha, what is A into B? This A into B. This is length into breadth. And what is length into breadth? Yes, length into breadth is what? It is area into B into sine 90. That is sine theta. So if you check about torque, so your torque will be equal to IAB sine theta. If you add up the number of turns, your N, it will be NIAB sine theta. The torque will be NIAB sine theta. What is NIA? What is current into area? Current into area is nothing but current into area is magnetic. Yes, it is magnetic dipole moment. Number of turns into current into area is magnetic dipole moment. So it will be torque is equal to MB sine theta. So that MB sine theta will be what? If you remove sine theta, it will be M cross B. So your torque will be equal to what? Your torque will be equal to M cross B. Okay. Yes.